Hello, this is Vedant Rai, SAP ID 60001180061 from B4 batch of TE Electronics. Today I will be presenting experiment number 6 of my DLIC practical. The aim of this practical is, there are 4 parts. The first part is designing an inverting and non-inverting comparator. Secondly, we'll design a zero crossing detector. Third, we'll design a time marker. And finally, we'll design a sample and hold circuit. We start with the inverting and non-inverting comparators. As we know, a comparator is a circuit which takes two analog inputs and gives one digital output. Um, it compares the values of the two inputs and gives the output accordingly. First, we see an inverting comparator. In an inverting comparator, the input voltage is given to the inverting terminal while the non-inverting terminal is given a reference voltage with respect to which we compare the input voltage. When the Vn is less than the Va reference, then the comparator saturates towards positive saturation, and similarly when the reverse is true, when the Vn is greater than the V reference, then the op amp will saturate towards negative saturation. Now we'll see a non-inverting comparator. In a non-inverting comparator, the Vn is given to the non-inverting terminal while the reference voltage is given to the inverting terminals. When the input voltage is greater than the reference voltage, then the comparator will saturate towards positive saturation, while when Vn is less than V reference, it will saturate towards negative. We'll now see the circuit diagram for a active comparator. This is a circuit for an active comparator. I've given a 2.5 volt reference and I've given a 5 volt sine wave as the Vn, and with 50 Hz frequency. I'll now run it. Input the sine wave and output. We are getting what we expect when the V reference is around 2.5 volts. So when the sine wave, the V input, which is a sine wave, goes above the 2.5 volts, then then the output goes towards negative saturation. Similarly, when it goes below the reference value, it goes towards positive saturation. We can change the frequency and see it. If we go to 500 and we change the stop time to 20, and we'll get a similar output. We run it, we get a similar output with some changes in the quality of the wave. We'll now see the circuit for a non-inverting comparator. This is the circuit for the non-inverting comparator. The input I've given a 5 volt sine wave. I'll take it as 50 Hz. Well, the reference voltage is 2.5. I will run this. To change the stop time, I'll change it to 200 ms and I'll run it again. And I'm getting exactly the Vref is 2.5. So when it goes above 2.5, it goes towards positive saturation, and while it goes below 2.5, it goes to negative saturation. We can change the frequency to 500 and we'll change this to around 20. We should get a similar wave, and we get a similar wave. We'll now see the next part, which is a zero crossing detector. A zero crossing detector is it's a voltage comparator only, but it changes output between plus Vsat and minus Vsat when the input crosses zero reference voltage. This is a circuit. In this you have to give Vref as 0. That's the only change. I'll now run the code. As we can see, when the value is 0 and it is going towards the negative, it goes towards the negative, and again after it crosses 0 it switches to positive, next 0 negative, then positive, and that's all in this part. We'll now see the next part, which is a time marker generator. It is the initial part is the zero crossing detector. When the input is a sine wave, the output is a square wave. This square wave is then passed through the RC series circuit. If the RC is small compared to the time period, then we get a series of positive and negative pulses. If you pass these positive and negative pulses through a clipper, then you can eliminate the negative pulses. Um, so this is a circuit diagram. We have a capacitor, 0.1 microfarad value. The input voltage I've given as 5 volts, 1k frequency, and I'm ready. And the reference one is the 0. It's connected to the ground. I'll run the circuit. As you can see, we are getting the pulses we are expecting. The diode and resistor, they serve as the clipper and they remove the negative pulses. We'll now see the final part of this experiment, which is the sample and hold circuit. Sample and hold circuits are basic electronic circuits which create samples of the inputs given to them. We will now see the circuit. This is the circuit of a sample and hold. This is a sample and hold circuit. The input I've taken as a 1k frequency, 1 volt, and the V control voltage is a pulse. We have taken these characteristics. The first op-amp I've used is LTC6244. The output is feedback back into the input. Similarly for this one, and there's a MOSFET. I'll now run the circuit, and I can see the input and the output. And as we expected, we are getting the sample of the input circuit. There's a bunch of step waveforms in the middle of the input sine wave. That's all for this experiment. Thank you.